Unlike Newton's first and second laws, which describe the behavior of a single object, Newton's third law of motion involves two separate distinct objects. To demonstrate Newton's third law, an aluminum reaction cart will be used. Steel ball bearings are loaded onto the sloping top deck of the cart and allowed to roll backwards, eventually exiting the cart at the chute. During this first stage of motion, the cart is observed to roll forward as the balls roll toward the back of the cart. This motion is not the result of an external force, but rather is due to the changing position of the cart's center of mass. In the absence of external forces, the center of mass of the system must remain at rest in accordance with Newton's first law of motion. As the steel balls roll down the track and to the rear of the cart, the center of mass also shifts toward the rear of the cart. In order for the center of mass to remain in a stationary position, the cart must move slightly forward. As the balls complete their motion, they are projected backward by the cart's chute. But in response, the cart accelerates in the opposite direction. This is a result of Newton's third law of motion, which states that for every force there is always a second equal and opposite force. Initially, the chute applies a force on the ball, pushing it backward. In response, the ball applies a force on the chute, pushing it and the cart forward. These two forces are equal in magnitude, but opposite in direction. Notice that the two forces do not cancel each other due to the fact that each is acting on a separate, distinct object. The steel balls, receiving the same force as the cart, obtain a greater velocity than the cart due to their smaller mass. If an entire row of balls are placed on the deck, the cart experiences an additional force from each individual projected ball. A jet engine operates in much the same way, receiving an additive force from every gas molecule exhausted from the engine.